Welcome to E Squared Emporium, all things AP Psychology. And today we're going to be looking at statistics part 3, inferential stats. So to infer means that you take a small amount and because you believe it's really good stuff, you think that therefore it must apply to the whole. So if you were to take your hand and go into an M&M's bag and you pull out a blue one, then they must all be blue. That would be an inference. Of course, you'd be wrong, but that's secondary. Okay, so inferential stats. We make generalizations. Key word. Okay, this will be on the AP test. Always is. So you see on the right-hand side that we've got a couple of people, and then the arrow says whatever is true about the few people must really also be true for the most part about the large group of people. So we determine whether the difference in scores between the experimental and control groups is really due to the effects of the IV, meaning independent variable, or just due to random chance. Does chance matter? All right, so think about it. Would you take an airplane flight with a pilot who just barely passed by chance? Well, probably not. And would you want a brain surgeon operating on you who passes exam by chance? Well, sure. Okay, so that's what we're saying. The chance is something we want to get rid of. Okay, so yeah, there you go. All right, probability. Again, if you already understand stats, and this is pretty introductory for you, but for most of us, that is not the case. So, probability, you see the letter P stands for p-value. Okay, that threw a couple of people off. I think it was 2 years ago on the exam, and everybody got really nervous. We didn't know p-value. We only knew probability, and we didn't want to make a mistake, so this was an FRQ. Anyway, p-value, there you go. So what does it tell us? Well, probability tells us statistical significance. All right, so think about it this way. If we say that a blue pen leads to higher test scores, how do we know that's true and not just random chance? Well, this is where this comes into play. So we take the results of people's test scores who took it with blue pens versus a different color, okay, or even typing, whatever we want to throw in there, and then we set up some sort of experiment because we want to get rid of the belief that blue pens equal A's. We need to know that it's really cause and effect versus just random. All right, so you see the p-value. Probability is less than 0.05. So if you translate that, what we're saying is that up to 95% of, let's say, blue pens and A's, anything under 95% of that happening is due to chance. Whereas if it's higher than 95%, we're now getting into the term likely, strong relationship, and then of course we get into the fact that it's going to happen. Okay? So you'll see a p-value of less than 0.05 or less than 0.001, which means it's going to be basically an outlier when it doesn't happen. Okay, so we get into test of significance. We're really in psychology trying to show that if we have a true independent variable, did it make a difference on the dependent variable? Okay, did bringing in the blue pen really make people perform better? So if it does, then we can say it's statistically significant. Otherwise, it's chance, it's random, we can't believe it. Because remember, we're trying to make determinations about how to create a positive response to symptoms in psychology, maybe how to treat it medically, maybe how to treat it with therapy. We don't want to just do this with random results. We want to know that there's a really good reason to do this and hopefully have a really strong outcome. So if you cannot prove 95% or better, then you must accept the null hypothesis and you start over and you're going to create a whole new hypothesis because what you were doing, the blue pen and A's, isn't true. I mean, maybe it was air conditioning in the room. Maybe it was sunlight. And we found that to be true. That sunlight has a direct impact on test scores versus being in a complete windowless room and no skylights and working under fluorescent light. Scores are much lower. That's been proven. All right, so we have a test of significance, right? You should at least by name, you don't have to calculate any of this right now, but you certainly ought to, have recognition. So t-test, a chi-square test, a z-score, Wilcoxon test, these are all techniques where we come up with this notion of probability and where we can move into, definitive cause and effect stories. All right, new this year is effect size. So what we're saying is that it really matters to have a larger sample group to get validity. You can't just say I studied 3 people in a school of 1,000 kids and those 3 did something, therefore we can make a conclusion or draw a conclusion about all 1,000 kids. Okay, that's a perfect storyline of why we need to have effect size, which means we need to look at the proper representation of a sample. You'll see that quite a bit when we get into some of the FRQs, and they're trying to trick you. They're trying to say, hey, if 6 people did this, is that good enough? Or let's say it's only women or only men. You start to see that, hey, wait a minute, you're kind of skewing the data here. We don't necessarily believe this is going to be accurate. In other words, we can't really generalize this data. Again, more story as to why it is that we need to have proper sample size or effect size. Okay, so it's good to have a small study. That's all true, but a small study may not be something that represents the larger group. The difficulty with large studies, what you see on the right, is, look at that number, 800,000 people. That's a whole nother dimension of how to get 800,000 people to participate. You may only need, let's say, 40,000, but 800,000 was deemed to be better. Well, okay, but then time moves forward. All of a sudden, it takes you 5 years to collect this data, and what you started with is very different than what happens 5 years. Think about it. Here we are today. Think about what life was like pre-COVID in the U.S. and in the world, and we have different answers. So that's why time may not be on your side here. Okay, that's it for now.